Alright, let's solve the Leetcode problem. Hope it is not divisible by something. Alright, alright, even if it's not divisible by something, it's a hard question. So the given question is 2141 maximum running times of n commuters. So we have n commuters, which is given in the n parameters in here. And then we are given an integer n and 0 index integer of array of battery, where each index means the battery that can run for the battery of index minute. So we are interested in running all the n commuters simultaneously using the given battery. Initially, we can insert at most one battery into each commuter. So after that, any time moment, we can remove the battery from the commuter and insert another battery any number of time. So that sentence in here mean like even the battery is tired, we can swap it out with the other battery, and then that insert battery can be totally new battery or maybe the reused battery from another computer. And we can assume that removing and inserting the process take no time. So we are totally ignoring the process of removing and inserting the battery into the laptop. Note that okay, the battery cannot be recharged. That makes sense. And then we have to return the maximum number of minutes we can run all the n computers simultaneously. If we go for the estimate in here, we have 3 batteries in here. So each battery lasts for 3 minutes. I have prepared something. Since I cannot find anything that much look like a laptop, let's consider this is a PC or computer, and then we have 3 battery. Let's consider 3. So originally will be the green. That means it's like fully charged. So we have 3 battery each in here that can last for 3 minutes. According to this estimate, we insert the index 0 battery. So this consider index 0, insert in here, and then battery 1 in the second commuter. So the time we have passed by something like 2 minutes. Just write it down like 2 in here, 2 is in here. So that's going to drop the battery percentage to the 1 minute each. So in the last time of the 1 minute, it is stated that at the end of the 3rd minute, after the 2 minutes, remove the battery 1 from the second commuter. So we're gonna swap it out and we can make it red because we don't have like that much battery percentage left. And then we're gonna pop the our remaining battery in here. So at the end of the 3rd minute, so battery 0, which is here, drain. So this became 3. Let's update this, where it began the 3. This also became 3, and then this one became 2, and then this became the 0. So at the time we swap this battery with this one, and then this will become like 4. I will just draw it as a 4 in here, and then this will also become 4, and then this will become 0. This will become 1. So we want to know the total simultaneously running time for that PC. So that is the result of 4, what we got. Then that outputs it in here. So for the next question, if we want to understand that, for the estimate 2, we are given like a 2 PC and then 1 for battery. But that is more straightforward than the previous. Let's consider like 1, 1, and then we have another 1, 1. So yeah, that is the answer already. Like we can run the battery 1 by 1 each. That will add up the 1 minute to the each device. The same for these 2 devices in here. So total will be the 2. Yeah, I think that is a pretty much greedy algorithms in here. So normally, even though I don't know how to solve it, I know the pattern how to solve that greedy algorithm. So normally what I do is, according to the checking the topics in here, that is definitely the sorting and some of the greedy algorithms in here. So what I'm going to do is, if I'm sure that it's a greedy algorithm, I'm going to sort it out, the given array, whatever it is. So let's call this as a battery in here. I'm going to sort the descending. That means like we are ordering from like greatest to the smallest, $0, which is the parameter one, and $1. And then we may need the total, which will be the battery of reduce into the total numbers. So in that case, that would be the 9, and in that case, that would be the 4. So next is we're gonna keep track of the index. If everything went well, we can move to our next important step. So which will be the while our index is less than the sorted array of cow, and what I'm going to do in here is I'm going to compare the each largest battery inside this sorted divided by comparison with the total. Total mean like we have a total numbers of battery performance. Let's say in here that is a 4, in here that is a 3. So the total, we want to check the absolute total of each index. How can we get it? We can get it by detecting the index from the given numbers of the BC. So let's say we are in the index 0, and then we have 2 given divides. That means like we need to divide the total by remaining numbers of the PC, which is 2. So after we receive it, what I'm going to do is I will gradually detect the total power of battery from our sorted index, and then just increment that index by +1. So for the next step, what I want to do is just return the answer. So that will be pretty straightforward by dividing the total with the total number of BC divided by the index. Yeah, that's pretty much of it. If I am not wrong, the runtime complexity will be the O of n log n, since we are using the sort in here. Let's try to submit it. And then the space complexity will be the O of n, since we don't use any other extra memories. Let's check it out. So this is the space complexity, which is O of n. Since we just iteration through the array, and then the time complexity will be the O of n log n. Yep, that's pretty much it, and see you in the next one. Bye.